Hello and welcome to question 14 of the GCSE 8300/2H higher tier calculator paper. And in question 14 we're told a pattern is made from two similar trapeziums. If you are doing an American exam and you're just looking at this for reference, in Britain we call this shape a trapezium. It's got two parallel lines. You would call it a trapezoid, but we call it a trapezium. Okay, so we're told show that the shaded area is 294 centimeters squared. So the way to do this is to take the area of the whole big shape and subtract the area of the smaller shape. The big shape is quite easy. We just use the normal formula, so that's this length plus this length over 2 multiplied by this length. So that's 18 plus 10 all over 2 times 25, which is equal to 9 plus 5 times 25, which is equal to 14 times 25. In fact, I will use a calculator for that. 14 times 25, 350. So the area of this whole shape is 350 centimeters squared. Now we need the area of the small shape. We have this length, but we don't have these lengths. But that's okay because we're told that these are similar. The word similar has an important meaning in mathematics. It means that the one shape is a scale model of the other. So if we can scale this up or scale it down, and it's the exact same shape but just different size. So if this is the exact same shape, that means the ratio of this length to this length is the same as the ratio of this length to this length. So since the 10 centimeters has been shrunk down to 4 centimeters, then this length here is 4 over 10 times 18. So if I write this down here, 4 over 10 times 18 is equal to, so that's 0.4 times 18, 7.2. Now we're looking for this length down here, which again is a scaled version of this 25 centimeters. So it's basically 4 over 10 times 25, which is fairly obviously 10. Just in case it's not obvious, 4 times 25 is 100, 100 divided by 10 is 10. So we now have the area of the small shape is 4 plus 7.2 over 2 times 10 is equal to 4 plus 7.2 divided by 10 times, no, not divided by 10, times 10 again, divided by 2 times 10 is going to be 56. I noticed the 5.6, and so to make that times by 10, you just move the decimal point one place across. Okay, so our area equals 350 centimetres squared minus 56 centimetres squared. 350 minus 50 is 300, 300 minus 6 is 294. Okay, in question 14b it says the pattern has one line of symmetry. Okay, well it's clear that that line of symmetry is going to go straight down the middle there. If you held a mirror there, you could recreate the shape just from that half of the shape. Work out the size of angle X. Okay. If I make a triangle out of this, I can... oh no. Okay, let's try and make a triangle again. And to try and make it look neat, but okay, there we go. So this is a right angle triangle now. We know this length is 25 centimetres. At the moment we don't know this length. However, if we make another triangle here, we have two triangles and a rectangle. We know this length here is 10 centimetres because it says so here. So this length is 10 centimetres. The whole length is 18 centimetres. So this length here plus this length here is going to be 8 centimetres. And since this length here has to be equal to this length here because we've got our line of symmetry down the middle, then we've got 4 centimetres here and 4 centimetres here. So this is 18 minus 10 over 2, which is 4 centimetres. And of course this will be 4 centimetres as well. Okay, and this of course is 25 centimetres. So this angle here, this is the opposite over the adjacent, which is tan x. So tan x equals 25 over 4. So x is equal to the arctan of 25 over 4. Which we can stick in our calculator. 25 over 4, and then inverse tan gets us 80.9 degrees. Yes, always make sure your calculator is in degrees if you want the answer in degrees. Too many people lose marks because their calculator set on either gradians or radians. We're given measurements here to 2 significant figures, so I'm going to round this to 2 significant figures and say this is 81 degrees.